Linear equations 2. We'll now take what we've done with the elementary equations and build more complex equations. So we'll carry on with example 5. (2x plus 3 is equal to 11). Now, developing the ideas from linear equations 1, we first need to isolate the x's, so we take the 3 to the other side of the equation, and we get 2x equals 11, but if we carry something across the equal sign, it changes sign, so the plus 3 becomes minus 3. Then we have 2x equals 8. To find x, we simply divide the 8 by how many x we have, 8 divided by 2, to give a final answer of x equals 4. And we can check that back in the original equation. 2 times 4 is 8, plus 3 does indeed give 11. Example 6. 5y minus 7 is equal to 8. Again, isolate the y's by taking the 7 to the other side. This time we get 5y equals 8, and the minus 7 becomes plus 7. That gives me 5y is equal to 15. So y is equal to 15 divided by 5. Final answer, y equals 3. Moving on to example 7. 7m plus 22 is equal to 4. Isolate the m's by taking the 22 to the other side, and we get 7m is equal to 4 minus 22. So 7m is equal to minus 18. Again, we get m by dividing the minus 18 by the amount of m's we have, minus 18 divided by 7. A negative divided by a positive gives a negative number. 7 goes into 18 twice, 4 left over, so it's 2 4/7. If we divide them by 7, the remainder tells us how many sevenths there are, in addition to the whole numbers. Right, now let's move on and look at equations with x's on both sides. Example 8, 7x minus 11 is equal to 3x plus 21. Here I'm going to bring the x's to the left-hand side and take any term that doesn't involve x to the right-hand side. So I'll have 7x on the left-hand side. If I bring the 3x across, it's positive on the right-hand side, so it changes to negative when I bring it to the left-hand side. Equals, plus 21 is already on the right-hand side. It doesn't move, so it doesn't change sign. But the minus 11, when it comes across, changes to plus 11. Now simplifying both sides, 7x minus 3x is 4x, equals plus 21 plus 11 is 32, or plus 32. So x is equal to 32 divided by 4, to give a final answer of x equals 8. And you should check your answer. If we go to the top line, 7 multiplied by 8 will be 56. 56 minus 11 would be 45. So the left-hand side of the equation would be 45. The right-hand side, 3 multiplied by 8 will be 24. 24 plus 21 is 45 as well. So we have a true statement, 45 equals 45. A little check like that can avoid any arithmetic slips you've made on the way. Let's have a look at two more of these kind of equations. Example 9. 5x plus 3 is equal to 21 minus 4x. We could take the x's to the left-hand side or the right-hand side, but I suppose out of habit I tend to bring everything to the left. So 5x, if I bring the minus 4x across, it becomes plus 4x. Equals 21. Notice, because the 21 was already on the right, it doesn't change sign. It's the 3 that changes sign. When I bring it across, it becomes minus 3. So the left-hand side, I have 9x, and the right-hand side, 21 minus 3, is 18. So x is equal to 18 divided by 9. Final answer, x is 2. And if we substitute that x equals 2 into the top line, 5 2s are 10 plus 3 is 13. And on the right-hand side, 4 2s are 8, 21 minus 8 is 13. So I'm confident 13 equals 13. I've found the right solution, x equals 2. Finally, example 10. 4x plus 7 is equal to 7x minus 17. Right, if I bring the x's to the left-hand side again, 4x, the 7x, when it comes across, becomes minus 7x. Students sometimes forget to change that sign because on the right-hand side it doesn't say plus 7x, it just says 7x. But of course we mean plus 7x when we don't put the sign in front of the first term. The right-hand side, minus 17 is already there. Take the plus 7 across and it becomes minus 7. Now 4x minus 7x is minus 3x. And collecting together, minus 17 minus 7 is minus 24. To find x, we simply divide by the amount of x's we have. So it's minus 24 divided by minus 3. And the signs take care of themselves. A negative divided by a negative is a positive. 24 divided by 3 is 8. So the answer is x equals plus 8, or simply x equals 8.